Welcome to the lesson on points, lines and curves. At the end of this lesson, you will be able to identify, here's Sam. What is he doing? Looks like he's putting up a banner of his favorite football team. And here's his sister, Anne. Let's see what she is doing. She's marking the location of the capital cities of India. Can you see anything common between these two activities? Both Anne and Sam use dots to mark the required locations. Knowingly or unknowingly, they're using geometry. The term geometry is derived from the Greek word geometron, which means Earth's measurement. Geometry is the most practical branch of mathematics. Some of its basic ideas took root during ancient times. Ancient civilizations like the Egyptians, Greeks, and Romans used geometry to build great cities and magnificent monuments. The proof can be seen in ancient monuments like the Great Pyramid of Giza, the Parthenon, and the Colosseum. Today, almost everything we do in our daily life involves geometry. Geometry is used by architects and engineers to construct buildings, bridges, and roads. Pilots, sailors, and astronauts use the knowledge of geometry to navigate boats, planes, and spaceships. Astronomers use geometry to predict the positions of and distances between celestial bodies. Look at the beautiful sky. The stars look like dots. In geometry, dots are used to represent points. A point is used to represent a specific location or a position. A point does not have any size or dimension, which means it has no length, breadth, or width. Points are denoted by single capital letters of the English alphabet. For example, the points that we have here are read as point A, point B, point C, point L, point M, and point N. Now, let's join points M and N. As you can see, points can be joined in various ways. However, in which of these ways is the path that joins points M and N the shortest? Yes, here the path between points M and N is the shortest. The path that defines the shortest distance between two points is called a line segment. The line segment is denoted by bar MN or bar NM and is read as line segment MN. The points M and N are called its endpoints. The distance between the two endpoints of a line segment is the length of the line segment. Now, let's extend line segment MN indefinitely in opposite directions beyond the endpoints M and N. What we now have is called a line. A line is made up of an infinite number of points that extend indefinitely in both the directions. It is read as line MN and is denoted by an arrowhead above it. A line may also be denoted by small letters of the English alphabet. One and only one line passes through two distinct points. Hence, 2 points can determine a line. Now, let's take another point A and extend it indefinitely in one direction. What is formed now is called a ray. A line that is limited at one end and extends indefinitely at the other is called a ray. It is denoted by a single-headed arrow and read as ray AB. The point, the line segment, the line, and the ray are the fundamental elements of geometry. Remember, a point represents a location or a position and does not have any dimension. A line segment has two endpoints and a definite length. A line is limitless and has no endpoints. A ray has only one endpoint and extends indefinitely in one direction. Now, here are some points. Imagine that these points are marked on a sheet of paper. Let's cut the sheet into two. Now, some points lie on one sheet and some on the other. Next, imagine that these two sheets extend forever on all sides. What we now have is a plane. Unlike the paper, a plane does not have any thickness. So, the top of the paper that is limitless can be thought to be a plane. Based on the discussion, a plane is said to be a very thin flat surface that does not have any thickness and is limitless. Now, can we name a plane? A plane is always represented by a minimum of 3 points. So, the first plane can be called plane ABC, and the second plane can be called plane LMN. Next, let's consider plane LMN. Apart from points L, M, and N, an infinite number of points can be contained within a plane. Now, let's join some of the points to get 4 lines. In the first case, 2 lines are passing through point M. That is, there exists only one point that is common between the 2 lines. These lines are said to be intersecting lines. Intersecting lines always meet, cut, or cross each other at only one point. In the second case, the 2 lines do not commonly pass through a point. That is, there exists no point that is common to both. These lines are said to be parallel or non-intersecting lines. Parallel lines never meet, cut, or cross each other. Please note that both these pairs of lines lie on the same plane. Let's consider some points on a plane. We'll join these points to draw a line. Here, you saw that the line got traced along a straight path. Now, let's draw a line differently. The path of the line is getting bent. Although the line is still passing continuously through the points, the path traced is no longer straight. Such a path is called a curve. Here are some more examples of curves. Based on these examples, curves can be defined as figures that flow smoothly without a break. By this definition, even a line is a curve. It is called a straight curve. Commonly, a straight curve is called a line, and other figures that are not straight are called curves. Now, let's focus on just the curves. Can you see a difference between them? In these curves, the paths traced by the curves do not intersect, cut, or cross at any point. Now, look at these curves. The path of this curve intersects at point A. The path of this curve intersects at point Q, while the path of this curve intersects at multiple points. Curves that do not intersect themselves are called simple curves. Now, look at these curves. Their endpoints do not meet. Such curves are called open curves. On the other hand, in these curves, the endpoints join to enclose an area. Such curves are called closed curves. Now, for a closed curve, you can identify three regions: the interior of the curve, the boundary of the curve, and the exterior of the curve. We'll use endpoints to understand this further. The red-colored points are located outside the closed curve. This region is called the exterior of the curve. The green-colored points are located inside the curve. This region is called the interior of the closed curve. The blue-colored points are located on the curve. This is called the boundary of the curve. The interior and the boundary of the curve together form the region. You've reached the end of the lesson. In this lesson,